But there are some things that we should always look at first before we actually jump into that factoring of the trinomial. But the first thing that you should always look for, no matter if it's a binomial, 2 terms that we're looking at, a trinomial, 3 terms, or even if we have 4 terms that we're looking to factor, the first thing you should always look for is a greatest common factor, or a GCF. Let's look at this one here. So here I have 10x squared plus 35x minus 75. Before I do anything, I look to see, well, is there a number that divides evenly into 10, 35, and 75? And I actually want to look for the largest number that divides evenly into all 3 of those terms. That's what we call the greatest common factor. So it turns out that 5 goes into 10, 35, and 75 evenly, so I'm going to factor out a 5. So when I do that, this will be 10 divided by 5 is 2, so that's going to be 2x squared. 35 divided by 5 is 7, so that'll be 7x. And 75 divided by 5, that's a negative 75, so it'll be negative 15. Now this 5 that I factored out is going to be part of my final answer, so I want to make sure that if this is a quiz or a test, that I put that 5 over there in that blank, just so I don't forget about it, because that is a common mistake that I see people do, where they'll factor it out at the beginning, but they forget to put it and include it in part of their answer. So next, we're going to simplify the 2x squared plus 7x minus 15. Now that's we're going to go ahead and use the X box method that we learned about in the last video. So again, what we do is we put the first term, in this case now it's a 2x squared and a negative 15 in these 2 boxes. And what we do is we multiply the first and last term, just as a review. 2x squared times negative 15 is negative 30x squared. Put the 7x down here. So now, again, we're trying to find what 2 numbers multiply together to be negative 30x squared. The same 2 numbers added together give us a positive 7x. So the fact that when I multiply them together I get a negative tells me that my answer is going to be negative, and the fact that I add them together and get a positive tells me that my larger of these 2 factors are going to end up being a positive number. So let's try some different numbers here, like 6 and 5, for example. Well, if I had 6x minus 5x, that would be 1x. So let's try 10 and 3. If I had a 10x and a negative 3x, sure enough, they multiply to be negative 30x squared. When I add them together, they give me 7x. So then I'm going to put the 10x and the negative 3x over here, factor this down, so I'm going to look for the greatest common factor of each row and each column. So the greatest common factor of this row is 2x. Greatest common factor of this row is negative 3. Let's look at the columns. Greatest common factor of this column is x. Greatest common factor of this column is a positive 5. Double check. 2x times x is 2x squared. 2x times 5 is 10x. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. So my answer would be 5, and then it doesn't matter what order we put these in. I could say x plus 3 times 2x minus, x plus 5 times 2x minus 3, or I could have said 2x minus 3 times x plus 5. But either way, these 3 would be your factors. That would be the factored form of 10x squared plus 35x minus 75. So that's the first thing to look for. You always want to look to see, is there a greatest common factor? Now the next thing we're going to look for is not really that necessary, but if there's 3 terms, we want to look to see, is it a perfect square trinomial? Now, what makes a perfect square trinomial? That's what's underneath here in black. If we have something in the form ax squared plus bx plus c, my a is the coefficient for the x squared, the b is the coefficient for the x, and the c is my constant. So if I take half of b and square it, and I get the same answer as a times c, that means it's a perfect square trinomial. Now, if my answer is yes, this looks more complicated than it needs to be, but your answer would be either in one of these 2 forms. But if your answer is no, then you want to look to see, well, can it factor normally? And we use the X box method in that situation. Let's look at these examples here. Here I have 4x squared plus 20x plus 25. So I'm going to see, is this a perfect square trinomial? So I would take half of b. B is 20. B is just the 20. Half of 20 is 10. 10 squared gives me 100. Well, it turns out that a times c, 4 times 25, is also 100. So the fact that those 2 values are the same tells me it's a perfect square trinomial. So my answer is going to be in this form. It's where it's going to be two terms being squared. Now to figure out if it should be plus or to figure out if it's supposed to be a minus, if your middle term's a plus here, your answer is going to be two terms added together being squared. Now to figure out what those two terms are, you take the square root of the first term. Square root of 4 is 2, so this will be 2x. Take the square root of the last term, the c, square root of 25 is 5. Now like I said earlier, this second step, the second question that we're asking ourselves, is it a perfect square trinomial, is not super necessary. What we're doing here is we're just finding an extreme shortcut to be able to get to your answer. If I didn't recognize that this was a perfect square trinomial, could I use the X box method and get the same answer? Yes, I could. It's just that when you go to factor out of the box, you'd end up getting 2x plus 5 on one side of the box. You'd get 2x plus 5 on the other side of the box, which, if you think about it, means the same as 2x plus 5 squared. But if you didn't recognize that it's a perfect square trinomial, no big deal. This is just meant to be a shortcut for you. So look at the next one. Again, I could use the Xbox method here to simplify this, or first, if I look to see if it's a perfect square trinomial, it might make it a lot faster. Because if I take half of negative 12, that's negative 6. If I square it, I get a positive 36. Turns out 9 times 4 is also a positive 36. So this is an example of a perfect square trinomial. So I'm going to have two terms being squared here. The fact that it's a minus tells me my answer is going to be minus. So now I'm going to take the square root of 9, that's 3. So it's going to be 3x. Square root of 4 is 2, so that's going to be 2. 3x minus 2 squared would give me 9x squared minus 12x plus 4. So this is your second step, or the second thing we should look for before we start is if it's 3 terms, is it a perfect square trinomial? Well, what if it's not 3 terms? What if it's 2 terms? If it's 2 terms, you want to ask yourself, is it a difference of 2 squares? Now notice I have that underlined, the difference. Think about what that means. What does a difference means? What does that mean? It means that we're subtracting 2 terms and getting our answer would be the difference. So a difference is where we're subtracting 2 numbers. If we were finding the sum of 2 squares, that's not what we're talking about here. So let's look. If it's a difference of 2 squares, what does that mean? It means that you get an integer when you take the square root of the a value and the c value. So let's look at, and it's got to be a difference. We have to be subtracting. So if your answer is yes, then we're going to write, if you notice these two, square root of ax plus square root of c times the square root of ax minus the square root of c. You might recognize that form. It starts with an c, ends with conjugate. These are conjugates of each other. So hopefully you recognize that, but if not, that's how you want to recognize this, that these are conjugates of each other. So that's what your answer will look like. Again, it's not going to be looking as complicated as that. But if your answer is no, if it's not a difference of 2 squares, it's easy. Your answer is not factorable. And in that case, the only thing you could salvage is maybe if there's a greatest common factor between the 2 terms. If there is, then you'd factor that out, but otherwise there's nothing you can do with it. So let's look at these 2 examples. Here we have 25x squared plus 16, and then the other one is 25x squared minus 16. Well, the first one is not factorable. And the reason why is because it's a sum of 2 squares, not a difference of 2 squares. So we can't do anything with it. But let's look at the next one. Here we have a difference. We are subtracting. Can I take the square root of 25 and get an integer? Yes, square root of 25 is 5. Can I get a square root of 16 and get an integer? Yes, it's going to be 4. So this we can factor down to be the square root of a, so square root of 25 is 5x, plus the square root of 16, which is 4. Then we have the conjugate, so it'll be 5x minus 4. So remember, these are always going to be conjugates of each other. And again, the order does not matter. You could have 5x minus 4 times 5x plus 4 if you wanted to. Now, regardless of what our problem looks like, if I have 2 terms, 3 terms, whatever it is, the last step before moving on is to always make sure it can't be factored more. We want to make sure that it can't be simplified further. Let's look at this example. Here I have x to the 4th minus 16. So what I'm going to do here is I want to look, it's 2 terms, so is it a difference? Yes, it is a difference. Can I take the square root of each term? Well, the square root of x to the fourth would be x squared, so that's possible. And the square root of 16 would be 4, so that's possible. So I'm going to break this down to be x squared plus 4 times x squared minus 4. And I might say, great, I'm finished. I just factored this down, move on to the next problem. Well, the problem is we always need to make sure that we can't be factored any further. X squared plus 4, that's a sum, so I know that's going to be fine the way it is, but here I have x squared minus 4. That's a difference. We are subtracting, and I can take the square root of x squared and get x, and I can take the square root of 4 and get 2. So that part can be simplified further. The x squared plus 4 can't, but this part, can I highlight it? No, it's not letting me. But that part can be simplified. Let me do this. So for that, when you go to break that down, it's going to break down to be x plus 2, x minus 2, because the square root of x is just, or the square root of x squared is just x. The square root of 4 is 2, so I have x plus 2, x minus 2. And that would be your final answer. X squared plus 4 times the x plus 2 times x minus 2. So again, what we're looking at today are some special cases. But again, you always want to make sure that before you ever get started, you always want to look to see if it's a greatest common factor. And then if it's 3 terms, it's a shortcut if you can see if it's a perfect square trinomial. If it's not, just go ahead and use the Xbox method. If it's 2 terms, you want to see if it's a difference of 2 squares. And lastly, before moving on, always make sure it can't be factored any further. So with that, good luck on your assignment.